Hey everyone, so in this video I'm going to go through an example of how to solve a rational inequality. So this is a rational inequality here. X minus 2 over x is less than x minus 4 over x minus 6. You can tell it's a rational inequality because it has at least one rational expression in it. Okay, so for step one, for solving a rational inequality, we're going to want to make sure everything is on the same side of the inequality. So I'm going to subtract x minus 4 over x minus 6 from both sides, and we're going to get x minus 2 over x minus x minus 4 over x minus 6 is less than 0. So now everything's on the same side, and the inequality is all less than 0. Good. So now, once we brought everything to the same side, we're going to have to get this into one larger one larger rational expression. And to do that, that means we're going to want to get a common denominator and put these two together. So to get a common denominator, we need basically to make sure that the denominators are factored, and make sure that we have both or all the factors that are missing in one denominator in the other, and vice versa. So this is technically already factored. Right? So you're going to notice that in the first rational expression, the denominator is missing a factor of x minus 6. So I'm going to multiply the first rational expression by x minus 6 over itself. So we multiply both sides, both the top and bottom, by x minus 6, essentially. And in the second rational expression, all that's missing is a factor of x in the denominator. So I'm going to multiply the second rational expression by x over x, which basically means that we're multiplying the top and bottom by x. Okay, so we're going to expand out the numerators now. So x minus 2 times x minus 6 gives us x squared minus 8x over 12, and then we have our common denominator of x times x minus 6. Okay, expanding out the second one, we have so minus x squared minus 4x over x times x minus 6, and of course that's all less than 0. So now that we have this fully expanded in terms of the numerators and we have a common denominator, we might as well collect like terms. So in the first rational expression I have an x squared, and then I'm subtracting x squared from the second rational expression. Well, x squared minus x squared is 0. Okay, we have minus x in our first rational expression, and we're subtracting negative 4x. So negative 8x minus negative 4x is minus 4x. And then we have plus 12 from our first rational expression. And notice there is no constant in the second, so it's 12 minus nothing, essentially, which just leaves us with plus 12. Okay, and that's, of course, over our common denominator of x times x minus 6. And it's all less than 0. So if this were a rational equation, at this point we would basically take the numerator, and we would know that the only solution occurs where the numerator is equal to 0. Now, this is a rational inequality, which means that we have to take a somewhat different direction. Okay, but now that we have it in terms of a rational expression is less than 0, what we're going to do is we're going to try to create intervals, essentially. Okay, so and to get the intervals, we're going to have to get our x-intercepts, and we're going to have to get our vertical asymptotes. And the reason why we get the x-intercepts and the vertical asymptotes is that those are the places that the function can change from being positive to negative, or vice versa. An x-intercept is, of course, where a function touches the x-axis. If it touches the x-axis, it actually could pass through it, and if it does pass through it, we know that it changes from positive to negative, or vice versa. And at a horizontal asymptote, we know that the function either approaches positive infinity or it approaches negative infinity, and we know that that can actually switch from positive infinity to negative infinity on either side of the vertical asymptote, which means that the function can change signs there as well. So we want to find both the x-intercepts and the vertical asymptotes. So for the x-intercepts, we know that to get the x-intercept here, that's going to be where the numerator is equal to 0. So let's see, we take negative 4x plus 12, and we know that setting that to 0 gives us the x-intercepts. Okay, so solving this equation, we get 12 equals 4x, which means that 3 is our x-intercept. Okay, so for our vertical asymptotes, that's going to occur where the denominator would be 0. So we take our denominator of x times x minus 6, and we make that 0, and see what x values see what x values gives us a value of 0 here. So this is already in factored form, so that makes things pretty easy. We're going to get x values of 0 and 6. Okay, so x-intercept at 3, vertical asymptotes at 0 and 6. So that means that we're going to be creating intervals out of the values 0, 3, and 6. Okay? So to create our intervals, we're going to want to check values on the left side of 0, between 0 and 3, between 3 and 6, and after 6. Okay, so that's going to help us create our intervals. So to the left of 0, well, that's x values which are less than 0, right? So x is less than 0 is our first interval. So between 0 and 3, so that's 0 is less than x is less than 3. So between 3 and 6, that's 3 is less than x is less than 6. And then x value is bigger than 6, well, that's just x is greater than 6. Okay, so now that we have our intervals, we're going to take test values. Now, the first thing you might ask yourself is, okay, we're going to take test values, but what are we going to substitute them into? So what we substitute them into is our version of the rational inequality before we found the x-intercepts and the vertical asymptotes, where we have one big rational expression is less than 0. So that's going to be this guy here. So we're going to take test values, sub it into there, and we want our rational expression to be less than 0, which means we're looking for negative answers here. So for x is less than 0, I am going to choose -1. So I'm going to sub -1 in for x, and we get -4 times -1 plus 12 over -1 times -1 minus 6. That simplifies into 16 over 7, which is positive. So that means that x is less than 0 is not a solution. Okay, so for x is between 0 and 3, I'm going to take a test value of +1. So -4 times 1 over 12, or -4 times 1 plus 12 over 1 times 1 minus 6. That simplifies to 8 over -5, which is negative. Again, we want negative answers, so this interval is going to be part of the solution. Okay, for x between 3 and 6, I'm going to choose 4. So -4 times 4 plus 12 over 4 times 4 minus 6. That simplifies into -4 over -8, which is 2, and that's positive. So that means that this is not part of our solution, that interval. And then for x is greater than 6, I'm going to choose 7. So we have -4 times 7 plus 12 over 7 times 7 minus 6. That simplifies into -16 over 7. That's negative, which means that it is part of our solution. So now the solutions are just going to be the intervals for which this works, but we do want to make sure that none of the restrictions to this rational inequality are going to be part of the solution. So we don't want the x values that render the rational expressions undefined to be part of our solution. So if you look, the only restrictions are going to be x equals to 0 and x equals to 6. And notice that x equals 0 and x equals 6 does not lie within either of the two intervals that we solved for, which means that our solutions are just going to be 0 is less than x is less than 3, and x is greater than 6. So this has been how to solve a rational inequality. Hope it's helpful, guys. Take care.